Hello. Hope you guys did well on the quiz and you feel like you understood how to prove whether or not the triangles were congruent through SAS, SSS, or ASA. If you have questions on the quiz, you'll get it back next class. You can see how you did, and then of course make sure you are coming in for those lunchtime sessions or after school on Thursdays with Mr. Craig. If you feel like you didn't do well on the quiz and you were completely lost, it's never too early, so it's better to come in earlier and get your questions answered sooner rather than wait till the last minute for the test. In addition to the 3 postulates you've learned, I'm introducing 2 theorems. So remember, the difference between a postulate and a theorem is that a postulate, so if you are interested in seeing the formal proof of one of these theorems, because I'm not going to do them today, then please have a look in the book and you'll see it there. It'll give you a hint as to how to start it. Then you could try the proof on your own, and I would be happy to check it for you. So feel free to do that. But basically, one of the theorems is AAS. So it says of 2 angles and a non-included side. So remember, if it's AAS in that order, then this side is not included. It's a non-included side right here. So if 2 angles and a non-included side of one triangle are congruent to the corresponding 2 angles and a non-included side of another triangle, then the triangles must be congruent. So this is asking, is it true? Well, yes, it's true. You could construct it. You could go to Geometry Sketchpad. There's going to be one and only one other size triangle that would have those same measurements that could be constructed, unlike side-side angle. Right, so we have an angle, we have a second angle, we have an unincluded side. Why is it unincluded? Because it's not between these 2 angles. So AAS, AAS, and therefore these 2 triangles are congruent. So we would say triangle ABC is congruent to, well, if I went from A to B to C, I'm going to have to go from E to F to D. Remember, that order of that letters matters a lot because we want to identify their corresponding parts. So that's the first theorem. The second theorem is the HL theorem. So what does HL stand for? Well, it stands for the hypotenuse and the leg. And when you say this word hypotenuse, there's only one type of triangle that has a hypotenuse, and that is a right triangle. So the first thing you need to add to this diagram right here, I forgot to put on, is a right angle in that corner. That should have been given to you. So this is a right triangle. In your right triangle, you have 2 legs. So here are my legs. The 2 sides that meet at the vertex of the right angle are called legs. And then you have the hypotenuse. The hypotenuse is the longest side of a right triangle, and it is also opposite your right angle. So remember, we talked about opposite sides and opposite angles when we were discussing isosceles triangles. Well, in a right triangle, the hypotenuse is opposite the 90-degree angle, and it's also the longest side of the triangle. So looking at the theorem, it says if the hypotenuse and one leg, so only one leg is necessary, if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. So we're just doing a leg and a hypotenuse, or a leg and a hypotenuse. So that now puts us at 5 different ways to prove that 2 triangles are congruent to each other. The first 3 we learned were postulates. They were SAS, SSS, and ASA. And then the 2 we just learned today are our theorems, and they're AAS and HL. Okay, we're going to go through some proofs. We will use one of those 5 reasons probably for proving triangles congruent, not necessarily the ones we just studied, but it could be any of the 5. But what I've done here is I've made the pictures a little more complicated with some overlapping triangles. Right? So I want you to get used to seeing a little bit more complicated diagrams. So with our proofs, always start with the given information. So that should be automatic by now. We're going to automatically write all of the given information in the first line. And then I highly recommend that you mark all of the given information on the diagrams. So it says angle A is congruent to angle D. So angle A is congruent to angle D, so I mark that here. And then it says angle O is congruent to angle U. And then finally we have AO is congruent to side segment DU. So segment AO is congruent to segment DU. Well, if we look at our two triangles, here's a triangle, this orange one, right? That's one of the triangles. And then the other triangle is this green one here. So they overlap just a little tiny bit in this area. So it's not too tricky for your eyes to see, but you could separate them if that helps you. So if it helps, you might want to separate it and write the letters A, C, O. Put the double marks here, the single mark here, and the single angle mark there. And then our second triangle has the B here, the U here, and the D here. We have a single angle mark, single side mark, double angle mark, so I can see which parts are congruent to each other. So what are we trying to prove? We're trying to prove, and then we have a T here, and both of those sides. So we're trying to prove that TB is congruent to TC. Okay, well if I'm trying to prove that these two sides are congruent to each other, well look, there's a 1 and a 2 put here in the diagram, and whenever you have those numbers put in a diagram, remember I said to you, oh, you're probably going to use those. Well, if I look at the 1 and the 2, those are base angles of an isosceles triangle. If we're going to try to prove that those two sides are congruent to each other, right? If we're going to prove that TB is congruent to TC, then I'm creating an isosceles triangle right here. So the only way I can prove these segments are congruent is if I can prove that these angles are congruent. Okay, well, I can prove that these angles 1 and 2 are congruent to each other if I can prove these triangles are congruent to each other because they're corresponding parts. So right here I see, oh, I have an ASA. So I can immediately jump to triangle AOC is congruent to triangle what? Well, I went from A, single mark side, double mark. So I'm going to start over here at letter D, single mark, angle, single mark side, double mark angle. So it's D, U, B. Sorry, this is confusing right here. I apologize for that. Try to fix that up. Hopefully you wrote yours a little better. So why are these congruent? Because of ASA. Okay, if these are congruent because of ASA, then we know all of their corresponding parts are congruent. Well, this is at vertex B. Number 2 is at vertex B, and number 1 is at vertex C. So I want to look at B and C in the order of those letters. Are they in the same position? Yes, they are. Therefore, those are corresponding parts. And what do we know about corresponding parts? We know corresponding parts are congruent to each other. Corresponding parts of congruent triangles are congruent. CP, CTC. So now I know those are congruent to each other, and if I know those are congruent to each other, that means those sides opposite, going back to this original triangle, those sides opposite each other are also going to be congruent. So therefore, I can conclude with TB is congruent to TC. Now why is that? Well, what was given here? What was given was the angles. So we're going to do ITT sides. We're trying to prove that the sides are congruent. So ITT sides, I believe it's also known as Theorem 4.2. So it's either ITT sides, if you want to write that, or you can write Theorem 4.2. Okay, if you didn't understand parts of that or you want more explanation, just try to stop and see me during class later at the end of the day, or come in for a lunch session. Go see someone at lunch. Today is actually an after-school session, so you could come see me too if I'm in my room. Okay, moving on. This diagram is much more complicated, so let's look at the given information and mark it on the diagram. We have angle 1 is congruent to angle 2 is congruent to angle 3. Okay, that's not really helping me see what triangles I'm looking at. Then I have side EN is congruent to side DG. I'm making them different colors this time because I'm trying to see the triangles they're related to. So if I look at this side DG, I can follow along those vertices and create a triangle. So that triangle would be M as this vertex, D as this vertex, G as this vertex. And if I follow along the EN, I would go up here to make a triangle and go here to make a triangle. Right? I couldn't follow this one because I wouldn't come down to letter E over here. So this red triangle has an E as a vertex point, M as a vertex point, N as a vertex point. So now if I'm marking the angles properly, well here this is, sorry I shouldn't mark out my number one. This is number 1 right here. And so this number 1 is right here in this corner and that has a mark here on it. This is an angle 3. That angle 3 is in this corner, C of the blue triangle, and that has a mark on it. And then we said that given that EN is congruent to DG. So this is my DG. So I put single marks there. Okay, so let's fill out the given. Let's think about this for a minute. While we're thinking, we can fill out the given. Okay, let's go back. So we know that these parts were given. What else do we know? We're trying to prove that angle 4 is congruent to angle 5. So do they share a side? No, there's no shared side. Do they share an angle? Okay, well this M here and this M here makes you think they're sharing the same angle perhaps, but look up here. The M in this side is, or in the red triangle, is going from this red side to this right side. The M in this blue triangle is going from this side to this side. Are those the same angle? They might be, but we're not sure. There's no information. They're not the shared angle, so we can't use the reflexive property. Therefore, that can't be part of our proof. So we've got to look for something else. Okay, well, let's go back to our given information. We used this already. We marked that on our diagram. But have we used all of this? Well, we used the 1 and the 3. So my question is, well, what's the significance of this angle 2 in here? Well, let's go back and look at my angle 2. Oh, well, look at this. Right here, we have another triangle. And if these two angles, 1 and 2, are the same size, then what does that mean about side EM and side DM? So look here, side EM and side DM. Why am I putting 2 marks on it? Because the side, this is an isosceles triangle. And if my base angles are given as congruent, that means their sides opposite them, which are ME and MD, must be congruent. So that's my next line. ME is congruent to MD. Why? Because of the isosceles triangle, and we're proving again the sides are congruent. The angles were given as congruent. Angle 1 is congruent to angle 2. Therefore, we're trying to prove the sides are congruent. So it's ITT sides, or again, theorem 4.2. Now you can see that what is true here, that we have 2 triangles congruent. Triangle MEN is congruent to triangle, well, I went from 2 to the angle to 1, 2 to the angle to 1. So it's MDG. Why? Because of SAS. And then notice, where's my 4? My 4 is down here at the letter N. My 5 is up here at the letter G. So I can immediately go to angle 4 is congruent to angle 5. And why is that? Well, look at the order. N is in the same place, the same location as G. Therefore, those are corresponding parts. They're corresponding angles. And we know corresponding parts of congruent triangles are congruent. And that is our second proof. So now you can get to part 2 to see how to do the 4 problems below. Try them on your own first if you want to.